I spent the last 8 months designing and building a complete twin turbocharged power plant for my Nova. Then I broke it. I'm going to tell you what happened, what went wrong, what we learned, and what I'm doing now to fix all that, to go back and do it again, and even try and make a bit more power. Behind me on my right here is another 6-liter LS engine. I'm in the process of preparing this one, and we're going to put it back in the car and test it again and see what kind of differences we notice. So. What happened on the infamous dyno pull? Well, we made a lot of boost pressure, made more power than we planned to, ended up compressing and yielding a connecting rod, a bunch of rods that look something like that. Fortunately, no rods broke, and as you heard in the last video, the engine was still running after the pull. Oil pressure was good, crankcase pressure, no issues. Even coolant pressure returned to normal after the pull, so that was fine. But there was a ticking noise, and it turns out that the ticking noise heard with the engine running after that pull was a result of the connecting rods shortening and the bottoms of the pistons and the piston skirts touching down on the counterweights in the crankshaft as it would come around. And that was the result. After tearing the engine down and going through everything, it was surprisingly in phenomenal condition. I'm super impressed with this engine. It had 200,000 kilometers on it and it came out of a pickup truck. That engine served as the basis for what would be hundreds of passes on the motor and ran at all sorts of races across Canada and the US. My original intention with this engine was to replace the stock 350 small block that came in these Novas in 1970 on a student budget. The best value for money, the best horsepower per dollar, and the best reliability in doing that was going to come from the Gen 4 LS engine platform at the time. And finally now, with twin turbocharged configuration running methanol fuel, we made over 1,000 wheel horsepower, and the motor is still in overall great condition. Also, all the pins pushed out smoothly from the pistons and the rods. Made good oil pressure, would have got me home, no problem, but obviously down on compression and with the pistons hitting the crankshaft, making a nasty ticking noise. But bearings look great. Finally, one other detail, we found a spike in the coolant pressure as the boost passed 30 pounds on that run. We have here is the 823 square port LS3 style cylinder head that came off the car. And as you can see, the outer cylinders are shiny all the way around the perimeter, with the exception of some small discoloration here on the deck surface. And what I'm looking for is this dark discoloration that we see here on the middle two combustion chambers. Now this is indicative of combustion gases escaping between the cylinder head and the head gasket during high cylinder pressure situations. Okay, so what are we going to do about all this? This engine's very much a development platform. This is an opportunity to learn, to test stuff, try ideas, challenge some ideas, and see what the results are. We learned a number of things on teardown that lead us to believe that maybe this wasn't a fundamental limit on the connecting rod and the piston with sufficient fuel flow. So the first correction that we're going to make is we're going to increase the fuel system base fuel pressure in order to increase the flow capabilities of the fuel injectors. At the time, only running about 60 pounds of base fuel pressure, I was not planning for and expecting to make so much horsepower. So having the base pressure set this low, we ran out of duty cycle quite early in that run, in fact. So I'm curious to go back again with sufficient fuel flow and see if the pistons can live at this power level. I suspect that they can. Second thing, we're experiencing some combustion gas blow by the head gasket at the cylinder head. I don't believe that we found the limit of the MLS head gasket, and I really like the MLS. This is the MLS or multi-layer steel head gasket that came off the car. This is nothing special. This is a factory style head gasket. The one thing that is special is this is down to 3 layers. So this gasket only measures barely 30 thousandths of an inch. This head gasket still looks good. It's largely intact, still got the coating. O-ring. I'm using a concentric cutting tool on the bores to cut a receiver for a copper O-ring. In this case, I'm using a 40 thousandths copper wire as an O-ring with about 8 thousandths protrusion from the deck surface. So this 8 thousandths protrusion is going to increase the pressure at the perimeter of the bores on the gaskets and thereby increase the clamp load and the resistance to combustion gas forcing its way out of the sealing deck surface. LS head bolt test video that was done, real interesting analysis of tensile yield strength on a bunch of different LS head bolts and head studs. So I picked up a used set of a US made head stud, a little bit better material, and I'm hoping that this will provide a higher yield strength and therefore resist flexing on the cylinder head casting. So here it is, the new power plant is ready. Came together smoothly. The plan here is to learn something. This is going to go back in the car. We're going to go back to the dyno now and put this to the test. It's actually snowing today, but I hope that that's going to pass quickly. This combo is going to be paired back with the 4-speed manual transmission, the same single disc clutch that I've been using in the car. You know, I expect really great things out of this power plant. The last one served me super well and was really, really capable. So see you in the next video, most likely on our way to the dyno. If not, we're off to the track. We're going racing.